2017. So, anybody know? Anybody don't know who I am? Anybody knows who I am? So Adrian doesn't know who I am. All right, great. All right, so I'm the founder of a local company called Software Secured. We do application security services, training, and a bunch of other things. I'm the chapter founder and co-leader of OWASP Ottawa. Has been part of OWASP since 2007. Wrote one of the first versions of WebGoat. Anybody used WebGoat before? Yeah, you'll see my name somewhere in there. And finally, hacker, developer, and a father of two beautiful kids who likes to really, really wake up early. So if I say anything stupid today, I have my excuse. Please excuse me because I wake up really, really early. They get enough sleep deprived right now. All right, so what's the big deal? There's a new version of OWASP Top 10. Anybody familiar with OWASP Top 10? Anybody who's not familiar with OWASP Top 10? All right, awesome. What's OWASP Top 10? So OWASP, as all of you guys know, OWASP stands for Open Web Application Security Project. It was created as this neutral, vendor-neutral entity that is going to give guidance to the community about what are the prominent vulnerabilities nowadays that developers should be aware of. One of the first and probably most important projects of OWASP is OWASP Top 10, which is the top 10 vulnerabilities that are kind of like dominating or are kind of more prominent in today's web applications. Cool? So a little bit of a history of OWASP Top 10. So there was the first version was 2003, and then another version came out 2004, 2007, 2010, 2013, and then they stayed for 4 years until they created 2017. First version of the 2017, it had a lot of controversy. Talk to me after if you want to know why. I have a lot of views and a lot of rants about that version, which I don't want to inflict on you, so I'm going to skip that part. But if you're going to go to beers after, talk about it, I'm all yours. I'll buy you even beer. All right. So they came up with a more sensible version, right, late last year. What is the significance of OWASP Top 10? It's pretty significant. So it's used for two reasons: guidance and awareness. Guidance and awareness. So there's a lot of entities that uses OWASP Top 10 as guidance. By entities, I'm talking PCI, I'm talking US CERT, a lot of organizations that use OWASP Top 10 as guidance. In addition, it acts as a very good entry point to those who are new to application security. So imagine yourself coming very new to application security and you're overwhelmed with what's going on and you need an entry point to that world of application security. OWASP Top 10 gives you a pretty good entry point to that world, right? So how do they come with OWASP Top 10? Who decides on OWASP Top 10? So there's a team, there's a team leader and a bunch of people, and they make a public announcements for companies to submit their data as far as what are the commonality of the problems they are seeing. So companies like Fortify, Checkmark, Synopsys, Vercode, Bugcrowd, and a bunch of others submit their data, and then that team go and crunches this data together with their own opinion of what's going on in the AppSec world, and they come up with a top 10. Sounds cool? Any questions so far? All right, cool. So here's the new list. Black means it's a carryover from the previous version. Red means it's a new vulnerability that just introduced into the 2017 version. Orange means it's a merged vulnerability from the 2013 version. Okay? So we have injection, broken authentication, sensitive data exposure, XML, entity injection, broken access control, security misconfiguration, cross-site scripting, insecure deserialization using components with known vulnerabilities, insufficient logging and monitoring. Okay? I don't have time to talk about all of them, So we have time only to talk about the new entries in 2017 as well as the stuff that has changed. And we're going to touch base on the vulnerabilities that was kicked out from 2017 and whether I think, from my personal opinion, and I would like you guys to pitch in whether you think it should be kicked out from the
new the Intel Spectre and Meltdown vulnerabilities didn't make the list yet.
They're not web vulnerabilities.
Yeah.
Oh.
They did not make the list.
That's under A9 using insecure quotes.
Good point, good point.
By the way, what color is A9? I can't tell.
A9 is
It is
black.
black?
I'm sorry.
Okay.
A9 is black. So I'm gonna go a little bit deeper into A4, A8, and A10. Sounds good? Looking at the crowd, there's a bunch of people that can talk about this stuff way better than I do. So please, you know yourselves, please pitch in, right? Let's make this more of a conversation rather than a lecture kind of thing. All right. So the big one is external XML entity injection, right? XML, external XML entity injection. Say that 10 times. Anybody familiar with this problem? Right? Can anybody explain what that is? Lady, please. Did you raise your hands already? I thought you did.
Yes, it should be when you have, doc type or an entity in the document. When a parser reads that document, it'll go and read another file from the machine, or it might reach out over the network and reach something. And then that data will get returned back to the user who requested it, even though they shouldn't have had access to that thing.
Right. Right. You guys get that here? Right. So, to simplify this a little bit, if you have an XML, right, and this XML has external entity, and you have a parser, because you need to parse that XML, right? And this parser resolves the external entity, you're in trouble. Let me explain. So let's go part by part. So this is an XML that has an internal DTD. What's DTD? Document type definition, right? What's a document type definition? So starting from here till here, that's the DTT. So what that is that's basically a document that explains what is in the XML. So let's say that I am RBC and you are an insurance company and you want to consume my data. So we need to coordinate with each other how we're going to exchange that data. So this guy explains what's in the XML. So if you look here, it has an element called note, right? And this note has 4 sub-elements, one called to, one called from, one called heading, one called body, right? And then I go and explain element to, which is this guy, is a PC data, element from is a PC data, blah, 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 blah. So if you see here, there is note that has a sub-element called to, sub-element called from, sub-element called head, body, note. So all what I need to do, me as RBC, give you insurance guy my DTD and tell you, here is the spec of the XML that I'm going to send you. So now you know, when I send you this XML, now you know how to interpret it. Does that make sense? Right, great. That's an internal entity, right? What does an external entity looks like? So an external entity says, well, those DTDs can be very, very big, right? And programmers like shorter, more succinct stuff. So it's kind of like an include. For the developers in the house, it's kind of like an include. So maybe we can take all of that DTT stuff, put it in an external document, and just reference to that internal, right? So we took all of this stuff, put it in a file called note.dtd. Say that 10 times again. All right? And now we'll be able to reference that, so we don't need to put all of the file internally inside the XML. Make sense? Everything looks cool, right? What happens if that external reference had something like this? So I have an external entity, I call it test, and I reference test inside my XML. What's going to happen?
Enhance your password file. Maybe.
Right? So basically my parser, if external entity resolution is enabled, it will do what's supposed to do, which is resolve the external entity. Where's the external entity? This guy. Right? So it will try, it doesn't know that it shouldn't resolve the etc password file, has no idea. It's just an external entity that it will try to resolve. And all of a sudden, you will get back the etc password file. I'm going to explain a little bit more. So, how do you test for external entity resolution? First of all, you have to find places inside your application that accept XML and look at the parser. If the parser does not disable external entity resolution, you probably have a problem. Right? Here's a question for you guys. Why did that, I mean, XML is not new. XML is not new. Definitely XML resolution is not new. Why did that all of a sudden made it to OWASP top 10?
Probably because they find it in the web.
Because,
They find it
well,
in the web.
yeah, it's been found in the wild since a long time.
Most likely because commonly used XML parsing libraries have it on enabled by default.
Maybe.
Was it part of the big breach?
It was part of the big breach. It was a part of the big breach. That's one reason. Another reason is XML is being used a whole lot more with RESTful APIs, with all of those new technologies. It's either XML or JSON, right? One or the other. So there's a whole lot more usage of XML these days than before. Make sense? All right. So here are the steps that kind of like a blueprint if you want to see if you're vulnerable to this vulnerability. Look for areas in the target application that accepts XML. Test if the parser accepts and resolves external entities, and whether it resolves those external entities. Next, test whether you can make an outbound request. Because resolving external entity is one thing, but actually getting any results from the target server might not happen. There might be a firewall blocking outbound requests, a lot of other things that can stop that attack from happening. So the next step, so if you have an XML, the parser does not disable resolving the external entities, does not mean that you have a vulnerability. It's still something that should be fixed, but it's not as severe, right? Because I cannot exfiltrate anything outside of your server. Next, test whether you can make an outbound request. Finally, try to retrieve local files from the server. But if you can get all the way to here, that's pretty serious. If you can't get to here, damn, that's bad. Right? Yeah, please.
So even if in step 2 you find it's willing to accept an arbitrary file from the internet, you get a big problem. Right? Even if you can't get anything outbound, you're then into the wonderful world of, what was that thing that called itself a DTP?
Yeah, you're absolutely right. So what he's saying is, even if you're at number 2, you still have a problem, right? The only thing is that the attacker cannot see that easily, right? Unless there's somehow you can make outbound requests, or the attacker has other means of figuring out whether his DDT was actually executed. All right. So that's an XML. What would that do? Developers, pen testers in the crowd, what would that do?
Make an HTTP request for IP.txt.
Koussa. Oh, yeah.
Make an HTTP request to
Make an
specify-
HTTP request to this IP address. How does that happen? Where's that? So this is an entity. It's called XXE. right? And basically that entity is an HTTP address, is a URL, right? Going to whatever IP/tested extension. Inside the XML, I'm referencing this. So the parser will try to resolve this. This is kind of like a variable. So the parser will try to resolve it. It will see the ampersand will say, okay, I need to resolve that. So it will look, where do I resolve that? It will look inside the entity. What's in the entity? It's this HTTP, so it will try to call that URL. Right? So if you're sitting at the other end, at this IP, and you see a GET request coming from the target server to test.ext, yeah, please.
Is that a valid doc type? Can you just put anything in there? Or?
It might not be, just for illustration purposes. You didn't test it.
Okay.
IP address of the server.
Yeah, it could be a local IP address. It could be an external IP address. But yeah, I didn't disclose just illustration. But all right, what about this guy? What would it do? Building on the previous concept, what would this guy do?
Capture the password.
Still source code and send it to the hacker.
Steal source code and send it to the hacker. How does that happen? Where's that? How did that happen? Can somebody explain? How would that happen?
The
Sure.
stolen data is in the drill request and it will be sent as the header.
Stolen data is in the request and will be sent in the header.
Sent as the request. This
Okay.
Data that's being from
Okay. Anybody else can take a shot at it?
It's called parameterized external entity, right? So it's like a two-step.
Two steps, exactly. So where does it start? Where's the entry point? How do we read this? What's the best way to read this? Where's the entry point? The entry point is this guy, right? This is the first thing that the parser will try to resolve. This is the first variable inside the document. So it will try to say, okay, I see extend entity. Where is that? It's here. Oh, that's an external, so I'll try to resolve that. Where is that? I host that. I'm the hacker. I host that. What's in that file? This guy. So it will resolve it. And then the second thing it will try to resolve is inception. What's inception? It's another entity. And this entity actually calls back my server with another variable. And the last variable is stolen data. What's stolen data? Stolen data is this guy. And it's an internal file. And this actually is a real vulnerability against IIS that was found last year. For the .NET folks in the crowd, right? This seems familiar? I mean, Microsoft in general, not just .NET. Right? So this is a real vulnerability against IIS 7 that was found last year. So this guy calls this guy calls this guy, right? And then inception calls this guy, which loads this guy. Right? Make sense? Any questions? What else can it do with XXCs?
ASP.NET remote code execution.
Sorry?
ASP.NET arbitrary code execution.
Yeah, ASP.NET arbitrary code execution. That's one of the other things you can do with XXCs. So it's pretty serious, right? It's pretty serious. So you can basically almost get access, not almost, you actually do get access to the target server. And if you can get remote code execution, now you own the server. Any questions?
There's another explanation I like is with AWS, there is something called metadata API. So it's a multicast address that every AWS instance has, and that contain metadata. So if you can trick the parser to do an HTTP get from that specific URL, which is always the same, then you retrieve sensitive information about the AWS instance, like sometimes keys if it's misconfigured or version of the OS. So you saw like in step 2, you're able to make a request out.
Request
That's
out.
another example.
Yeah.
If you're testing against AWS.
Yeah. So the litmus test is to know whether, assuming you don't have access to the source code, if you have access to the source code, then you definitely know whether external XML entities are being resolved or not. But if you don't have access to the source code, then the litmus test is whether you can send an entity and that entity sends back, calls you back, right? Then that's kind of like the litmus test. Any questions?
Is send it a tool that is included in Windows Server by default?
I don't think it's doing anything, to be honest with you. But that was the real payload that was used, like, for that vulnerability, the IIS vulnerability. But I don't think it's doing anything because the data is already sent here. Right? Any other questions? All right. So a usual result you would get, like for example, if we were asking for, instead of this file, if we were asking for /etc/password, this is what you get. This is what you get. A lot of the old systems are vulnerable to XSEs. If they accept XML, there is a very, very good chance they are vulnerable to XSEs. Right? Any question? Cool? All right. Next is Insecure Deserialization. Why did it make it to OWASP Top 10? Because Java was found vulnerable in the last 2 years for a bunch of, not just Java, a bunch of, there's struts, Apache Commons, and a few other components that's Java-based that are found to be vulnerable to remote code execution through insecure deserialization. What's serialization to start with, or deserialization? What's that?
You're taking an object, you're saving it to disk.
You're taking an object and converting it into a stream of bytes. That stream of bytes, you can put it on disk, you can send it over the wire, you can do whatever you want with it. Right? So let me repeat that. You take an object, convert it into a stream of bytes. You can store that stream of bytes on disk, you can send that over HTTP request, you can do whatever you want with it. Right? Why would I do that? Why would somebody do that? Transfer data, exactly, right? Yeah, transfer data. So I'll give you an example. So for example, you have a session, right? There's a session on the server. So in that session, the session is complicated. So you have the user's ID, you have the user's preferences, what he did last, blah, 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 right? Assuming that you don't want or you cannot put this data into a database, for example, what other option do you have? Right? So you take that session, you store it on disk. The next time the guy come back, then you load it back from disk right into the memory and keep processing. Right? So let's look at an example of serialization and deserialization. So this is Java code, and what we're doing here is that we have something called demo. This is a class called demo. It takes 2 parameters, an ID and a string. So, and I have a file here that I'm going to serialize to and deserialize from. Make sense? Right. So the serialization part is I created a file, right? And I open a stream to write to this file, and I'm going to serialize that stream inside the file. So pretty simple. You take demo and you just convert it into you take demo, so that now it's an object because I instantiated using new, right? This guy creates an object. Here's the object, and then I put it inside the file. Make sense? And then here, I did the opposite. I read the object from the file, converted back into demo, right here. So I read the file, took a stream of byte, and then read the object back into an object, and that object is of type demo, right? So I took demo, converted into stream of bytes, put that stream of byte into a file, and then deserialization, I did the opposite. Read the stream of file from the stream of bytes from the file, put it back into the object, and typecast it into demo, and I back have it into the memory. Make sense? And if you actually open file.ser, this is what it looks like. Right? This is what it looks like. Here is your string. Somewhere in here there is the 1, right? But the data is stored as a stream of bytes inside the file. So what's the problem? What's the problem with all of that? The problem is this guy, object input stream, does not validate the deserialized class. So I can force the application to deserialize anything, not necessarily what was originally serialized into the file. So I can put any code inside the serialized bytes, and the application would deserialize it. Any code. So for example, let's say that you communicate over HTTP, serialized object, so I can insert myself into there, right? Put my own object, serialize it, and send it to your application. It will deserialize it and execute what's in there. Oh, hold on, Sherif, but there is typecasting going on there, right? So it's going to throw an exception.
Yeah.
Right? So there's no problem. Yes or no? Is there a problem? There's typecasting, and the typecasting will throw an exception, because if I put anything other than demo, if I put my own class, it will throw an exception. So we don't have a problem. The problem is, yes, this guy will throw an exception, but the object is already created. Right? So the object is already created. The code is already executed. The malicious code is already executed. Now, the program is trying to do it one step further, is to typecast it to demo. That is going to fail, but the malicious code already executed. Does that make sense? Right? So that is in Java, but different languages have other libraries to deserialize data, and there's similar versions in every language that would deserialize the data without, well, the main problem is not Java. The main problem is there is a class that deserializes data without having a whitelist, for example, of what it should deserialize. So it will just take any string of bytes and deserialize it, and it will try to execute it. Right? So how do you test for insecure deserialization? Look for areas in the target application that accepts objects. So for the pen testers in the crowd, how do you know that? So you have a bunch of HTTP requests going back and forth. How do you pinpoint this is a candidate for deserialization vulnerability? What's the first kind of like sign?
ACED05.
What?
ACED05, the first 3 bytes.
Why?
Well, that's in the protocol for this region.
So can you repeat that to everybody else?
ACED05, I think.
Okay. So one of the other things as well, if you see a bunch of base 64 encoded data, you decode that, and you would see something like this. right? You would see something like this. Or something similar, so you would know that this could be serialized bytes. Now I'm oversimplifying, right? But this is kind of like a starting point to how would you test for this vulnerability. Obviously, if you have access to a source code, look for object input stream.treat object or equivalent in your target language, .NET or PHP or what have you. And finally, find a way to get remote code execution, because this does not guarantee remote code execution, right? Being able to send your own does not guarantee a remote code execution. You need to have a way to execute the code that you're sending. Merely converting into an object does not guarantee that this object will actually execute code, right? You need to have a way for the method that you use for the constructor to be actually called and the code inside it to be executed. All right, any questions so far? All right, next is insufficient logging and monitoring. I have mixed feelings about this, right? Is this a vulnerability? Is it a best practice? Is it somewhere in between? I have no idea. Should it be on OWASP top 10? I can think of other things that should be on OWASP top 10, to be honest with you. But anyways, some very qualified people thought it should be on OWASP top 10, so we should discuss it. So, all right. So there's an issue that happens when the application does not log enough information, right, to aid incident response, or does not support repudiation issues. What are repudiation issues? What's non-repudiation? Please.
So, repudiation issues are where they can convincingly say, I didn't do that,
Yeah.
and you can't prove they did.
When is that needed? For example, can you give us an example of when it's really good to have repudiation controls? A bank transaction, for example, right? So $1,000 came out of your bank account. The bank needs to have enough logging controls to prove without a single shred of doubt that you are the one who made that transaction, right? And not somebody else. So if you take them to court, they will be able to present evidence that you are the one who actually made that transfer or not, right? Third, logs information that are not supposed to be logged, such as password, for example, right? So now that I'm thinking a little bit more, I think it should make it to OWASP top 10. Why? Equifax breach. Sorry, other question.
Lots of people figured that a system will get broken into somehow, eventually, almost for sure. And you've got to be watching for that.
Yep. Yeah, good point. So Equifax breach. Yeah, they got hacked because of the trust library they were using, but why? Why was it a big deal?
Release data.
Please.
They somehow didn't notice several terabytes of data leaving their network.
Yeah. So if they were logging and monitoring, probably they would have a better response, right, than what they did. Most of the time, the shit hits the fan, not because, yeah, shit hits the fan because there was a big breach, but it really gets worse if the company's response to that breach sucked, right? This is where they really have it tough, right? Having a good incident response plan makes a bad situation a little bit better. Not having the ability to respond to that incident properly make a bad situation really, really, really worse, right? So, what do we need to log? It really depends. It really depends on what your application is trying to do. What are the regulations that you're trying to satisfy? Are there any compliances that you're trying to satisfy? A bunch of things, but I always like to mention the 4 W's. when, where, who, and what. So you need a when, right? Such as date and time, right? When this happened, when this piece of log file, when did it happen? Where? So application ID, server ID, service ID, entry point, geolocation if it makes sense, data center if it makes sense, who, machine ID, user ID, license, so you know which client, for example, is responsible for that piece of log, and what type of event, severity, description, what happened, a little bit of description of what happened, right? So using that framework, I find it to be helpful in deciding because it is, you want to log stuff, but at the same time you don't want to overlog stuff because now navigating through the logs can become a really, really shitty job, right? So you want to log the right amount that makes it very effective for the incident response team to identify what happened, but doesn't make it really, really tough for anybody to read those logs without spending a few months going through the logs, right? What should not be logged, which is as important as what should be logged. So application source code, right, go to that. Somebody might be asking, why would everybody put source code inside the log? Oh yeah. Traces, SQL statements. Yeah, you did it. I did it. Everybody did it. We put SQL statements all over the place, right? Because we never know for sure which part is running and which part is not. So we need to see it inside the log, right? Personal information, full names, addresses, usernames, passwords, SIN numbers, stuff like that, right? What about wrong password? Should we put it in the lockbox? It's wrong password.
Not a good idea.
Well, it's not anybody's password.
Yeah, but it's close to, probably close to.
Aha, it's close, right? Most people don't put wrong password. They miss by 1 or 2 characters, right? So it's close enough. Please.
And some of them will get their username wrong and their password right.
Yeah, a lot of times you put you're in a hurry to log in, so you put your password inside the username, and that will end up being the server, right? And the server logs. Don't do that. Access tokens, bank accounts, stuff like that. Any questions?
One missing here, and that would be like unvalidated user input more generally, because you can do a lot of scripts by
Good point.
injecting logs.
Yeah.
Yeah.
Unvalidated user input. So any weird input that can really aid in somebody doing, that's a very good point.
Actually, just to kind of reiterate on that one, if somebody who has just done something nasty can now deface your log,
Yes.
then it's easier to cover your tracks.
Yep. So there's a bug category that is seldom talked about called log forging, right? You would see it when you see your beautiful library log.debug, for example, and you're logging something weird happened here, plus a variable that is retrieved from untrusted user input. So this is a log forging opportunity because now using the /r/n, right, carriage return line feed, I can enter a new line into your log files, right? So the single most nasty character for log forging is, right, is /r/n. Same with HTTP response splitting, right? The whole bug category is around the /r/n or whatever equivalent, right? So the ability of the attacker to add a new line in your logs, that is the problem, right? All right. So those 3 issues, please.
So what's the issue with the attacker adding carriage return in the logs?
Right. So I wish I have like something to write on, but imagine a log file, right?
Yeah.
And the log file usually starts with a timestamp,
Right.
right? And then usually there is an ID of some sort. And then usually a user ID of who's doing this.
So user session ID.
Something like that, to know who's doing that, which user. And then a description, right? And then a new line.
Yep.
But what if I'm the attacker, can force a new line into your log forging? You wouldn't know that. As a defender, as a developer, you wouldn't know. You would think, so for example, let's say that, I don't know, May 21st, blah, 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 Koussa, me, login. Koussa, transfer. Koussa, sign out, right? Koussa, transfer. So I'll call back, first transfer $1,000, second transfer for $10,000. So I'll call in and I'll say, hey, GC, I did not do the second transfer. You go back into your logs, you will see I did $1,000, sign out, and then another transfer. But what if I forced the second line of sign out? I didn't actually sign out. So now I just got $10,000 back because you will think it's fraud. All of this happened because I was able to enforce a new line. But what if I did the following? Timestamp, Koussa, login, timestamp, Koussa, transfer, $1,000. Timestamp, Koussa, sign out, transfer, $10,000. Right? So that's so different because it's not a new line. It's just, I was able to, now the program, you will trust your logs. If you see a new line, you will trust that your program produced that log. You wouldn't think that I forged that log sitting in my basement. Right? You guys see that? You guys see the point? Right, so this is it as far as new vulnerabilities that were added to OWASP Top 10. So just to recap, XML External Entity Injection, XXEs, Insecure Deserialization, and Insecure Logging and Monitoring. Now, they took two vulnerabilities from OWASP Top 10 2013 and merged them into one. So the two vulnerabilities called Insecure Direct Object Reference, known as IDOR for simplicity, and Missing Function Level Access Control. Missing Function Level Access Control. The easiest way to differentiate those two is this is on the record level. So basically the ability of the attacker to modify ID and get access to a different record, whether that record is inside a database, inside your file system, but basically we'll get another file. And this guy is basically the ability of the attacker to get access to a different functionality altogether. So, for example, a normal user who was able to brute force into the administration section by figuring out, oh, they have an administration section, it must be /admin. And you write /admin, and he's right there into the administration section because the server side doesn't have enough entitlement controls, authorization controls to ensure that a normal user does or does not have enough privileges. It was banking on the fact that nobody can figure it out. That /admin is the administration section, right? So this guy gets access, the ability of the attacker to get access to a different record by just manipulating an ID, right? And this guy is the ability of the attacker to get access to a whole functionality by brute forcing the name of that functionality or the way to get to that functionality, right? So those two were merged into broken access control. Right? Now, there's two vulnerabilities that got booted out. Cross-site request forgery, right? And what was the other one? Unvalidated redirection forms. Anybody know what cross-site request forgery is? We're not going to hear about it because it's not part of the OWASP Top 10, so you're going to hear way less about it from now on. Anybody know what cross-site? Anybody can explain what cross-site request forgery is? Please.
So usually the vector is you take it's the ability to inject the same response multiple times. Web forms tend to be open to this. So the way that you prevent XS commands coming in is you fingerprint the outgoing so that uniquely, so you know that the input was actually in response to a legitimate request. Because otherwise people can jump into the middle of your process engine and start executing things that you had no idea would be executed in that order.
So let me rephrase that. Let me rephrase that. So cross-request forgery is the ability of the attacker to force your browser to send requests you don't know about.
As long as you have an open session.
Sorry?
As long as you have an open session.
Thank you. As long as you have an open session.
Yeah.
So bear with me. You opened your laptop, you ran Chrome in one tab, you logged into CIBC.com, right? While logged into CIBC.com, you opened another tab where you navigated to hacker.com, right? In the homepage of hacker.com, on the second tab, hacker.com replied back with HTML that has a pretty nice image. Inside the source of that image, the following HTTP request: HTTP CIBC /transfer $to blah 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 ampersand amount equal 1,000, and send that HTML back to you. What's your browser going to do? It's an image. It will try to render that image, right? It doesn't care what's in the source, right? So it will try to render that image. So it will send a request to CIBC.com, right? CIBC.com will see a request coming, right? Will it honor that request?
Yep.
Why?
Because the cookies will be sent.
Because there's cookies, right? There's cookies sent. Why is that? Why are the cookies are being sent in the request?
Because you are logged in another tab.
Aha, you're logged in the other tab. So the browser is cooperating, right? The browser doesn't care whether the request to CIBC is coming from tab 1, which actually loaded CIBC.com, or it's coming from tab 2, which didn't load CIBC.com. Why would the browser do that? That's pretty stupid. One word, CDNs. Right? CDN stands for Content Delivery Networks, right? So a lot of times you will load something and your website is just grabbing images from here and grabbing JavaScript from there and grabbing CSS from here and grabbing HTML from there and grabbing blah 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 from there. Not all of the content that makes up a response is coming from one source. So the browser cannot restrict the source to be one domain. There's a bunch of other things that the browsers came up with, but we'll talk about that later, such as same origin policy and course policy and a bunch of other things. But in general, the browser will honor that request as long as, the CIBC.com will honor that request as long as there is a cookie attached, an identifier attached to the request, and that identifier is still valid, right? So let me give you guys an example. So here's the victim, right? Sends a post request, so it logged into a bank. Session established, session equal blah 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 blah, and it sends it back to the victim. While logged in, the victim goes to a website that the attacker controls, right? You probably don't see any of that. All right, anyways, that's a form, right? And inside the form, it has the bank's URL and a bunch of, so this is a to, this is the amount, and this is debit, okay? So, and this is a script that auto submits this form, right? So as soon as the victim visits the web, he doesn't need to click on anything, or she doesn't need to click on anything. They just need to visit, and this form will be auto submitted, right? The form will be auto submitted to the bank's website along with the cookie, because the browser will, this is what browser do, right? It will see a request going to bank.com. It will look inside, do I have a cookie for bank.com? Sure, send it along. Doesn't care whether that request is coming from tab 1 or tab 2. This guy have no idea whether the request is coming from tab 1 or tab 2, and it will just honor the request as long as it has a valid cookie. So that was cross-site request forgery. Now, the important question is, why did that get booted out? Looks like a legitimate request, a legitimate vulnerability. They do two-level validation. Okay? A lot of the banks, yeah. So my personal opinion is, since this guy made it, I think in 2010, there was no major breach because of cross-site request forgery.
Undetected.
Right? Undetected.
That's why they introduced the logging and monitoring.
The other thing, it turns out it's pretty easy thing to protect against, and a lot of the frameworks added built-in mitigation against cross-site request forgery. A lot of the frameworks, you just need to switch a button. Right?
The Spectre mitigation in Google Chrome prevents this as well. Okay.
Yeah. By default?
Well, no, you have to go in and make a modification in your advanced settings.
Yeah. Yeah.
So, can I make a comment? If there is cross-site scripting in the same application and parameters, cross-site scripting gives you cross-site forgery because you're in the DOM, you can use JavaScript or XHR to log any transaction you want, and including reading any tokens or submitting, are you sure, additional forms. So cross-site forgery is not going away anytime soon, and is very, very difficult to mitigate correctly. Very difficult.
So what Adrian is saying is, if you have cross-site request scripting vulnerability, then forget about all of your cross-site request forgery mitigations. And the reason why, if I can't execute JavaScript inside your browser, let me back up. The mitigation against cross-site request forgery is basically issuing another token that is not saved inside the cookie, that is saved inside the HTML. Why do we need 2 cookies? Well, we don't need 2 cookies, but we need to store something not inside the cookie. Because the main problem was the ability, actually the functionality of a browser to send the cookie along with the request. So now I need to store something in a different location other than the cookie, right? So if I have tab 1 that is loading cibc.com, and I have tab 2 that is loading hacker.com, if I submit CIBC, let's say that I stored that cross-site request forgery token inside the HTML, right? So basically I went to cibc.com, I logged in, and cibc.com on every response inside a hidden field will give me a token, right? So the next time I submit back to cibc.com, and because the token is inside the HTML, so I will send it, so that the token will go back to cibc.com along with the session, right? But if I loaded hacker.com, hacker.com will not have that token because it resides inside the HTML, not inside the cookie, right? Now, back to Adrian's point, if CIBC is vulnerable to cross-site scripting, right? So now I can, using cross-site scripting, I can parse the page, find the token, submit it along with my cross-site request forgery payload. So basically here, I will just add, another field that parses out the token from the HTML page. Because I can execute JavaScript, and using JavaScript you can do a lot of things, right? Any other question?
I think one of the other issues that was taken off was a lot of the websites didn't see it as their problem. I had a couple of clients that had CSR vulnerabilities and they said, nope, browser problem, we don't care.
Yeah. People, so what Gerald is saying is that developers or people writing software in general didn't think that it's their problem. They are thinking that it's the browser's problem. The browser should fix it. Actually, one of the things that put it out is unvalidated redirects and forks. Anybody can figure out what that is? So, for example, let's say that inside your application you have a little line that sends response based on untrusted data retrieved from the request, right? What if that response, that data that you retrieved from the request was a URL to a hacker's website? So people can use that for phishing, right? How? So I would send you a link that actually points to a legitimate website, so you hover on it, you will see blah blah blah.cibc.com. I don't mean to. Anybody from cibc.com here?
We just said for a while, yes.
Yeah, sorry, I mean.
Your interest rate just went up.
The good thing I'm not with cibc.com. So PayPal.com. Right? And so you hover over a link, you see PayPal.com, so you think that it's a legitimate URL. Nobody reads all the way to the end of the URL, and there's a little parameter towards the end of the URL that says redirect to equals http crappyserver.com. Nobody's going to do that. They will just read the first and say, oh, that's good, click on it. But what happens in the background? What happens in the background is you're going to send a GET request to actually eBay.com, right? eBay will send you back a 301, what's the 301? Redirect, right? To crappyserver.com. Oh, but now I'll know that I ended up on a bad server, I'm just going to close the browser. Oh, maybe not. So look at this. That's an email. Where does it come from? eBay.com, right? And it says blah, 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 blah. Either your information has changed. Please click here. Update and verify information by signing into your account below. If you hover here, it will say eBay.com, right? So you click on it. What happened? And you end up here. What's this?
Not eBay.
Not eBay, right? How did you know? From this guy, right? Because there's an IP that looks a little shady, or a lot shady, right? So what happened in the background is, you click here, right? It will go to eBay, but eBay has an insecure open redirect vulnerability that sends back a 301, right? Your browser will obey the 301, and the location of the HTTP response will be HTTP 211.blah. Right? A lot of people will just put their usernames and passwords and hit sign in securely. Now, if you are a pro, what would you do?
Realize that's not the current logo for eBay.
No, if you control this guy, if you control that server.
Register a domain that's similar to eBay?
Well, I will scrape eBay and put it on my server, but what else?
Store the credentials and then do a legitimate submit to eBay.
Excellent. Right? So I'm a victim. I got this email. I bought a bunch of stocks from eBay, so I want to continue buying stocks from eBay. So I want to change my information. So I look. Oh, this looks like eBay. Right? A lot of people will not notice this. So they will see that. They will put their username and password. They will sign in securely. If I'm a pro hacker, I'll take the credentials and sign you back into eBay so you wouldn't notice a thing. Right? So that was the significance of Insecure. It was used a lot. It was used a lot in phishing. Right? But it was booted out. Why? Why do you think? I have no idea, but I think they just ran out of places. Just ran out of numbers. OWASP top 11 doesn't make any sense.
Yeah.
All right. Any questions? Yeah, please.
Most web frameworks, when you're unauthenticated and you hit a page that requires login, when you go to that login page, it has a redirect to go back to wherever you're supposed to go.
Yep.
So do the frameworks validate that redirect URL usually is meant to be within your own site instead of an external URL?
Because the framework doesn't know how do you want to send back your user. I don't know the framework. I'm not sure if .NET does it. Java definitely doesn't do that. Java doesn't do anything, right? Maybe there's something in .NET with the new entity framework.
A lot of OAuth frameworks.
OAuth, yeah.
You register the valid return address when you sign up with the program, and so the login gets a different return address than what you do.
Yeah. So just for everybody else, so what Jesse was saying is there's a lot of other applications. For example, if you bookmark a particular page inside your application, right? And then you close the browser, went to eat lunch, you came back, and then clicked on that bookmark, but your session timed out. So for a usability standpoint, the application would save where you intended to go, but sends you to the login page, right? And because it's saved that URL that you originally wanted to go, it will, after the login, after the authentication process, it will send you back to this page. And this is during, like, the pen testers in the house know that this is a very good location to find open redirects places, because a lot of the times this happens. So, but this is for this particular functionality, it's a business functionality. It's not a framework functionality unless you're using OAuth. So basically, OAuth, you can save your return address, but I'm not sure what they do if your return address is not the home page. Like, for example, I want to go to an internal page inside the application. So
it depends what you're doing. Like, we've set up programs where you can ask for OAuth access to, say, Office 365. And you have to register with Microsoft.
Oh, I see.
Your application.
Oh, I see. So
your
whitelisting
application has a single endpoint that's allowed. Well, you can register more than one, but and whatever those endpoints are, those are the only ones that are allowed as a redirect. If you actually try to authorize the wrong redirect, it will not let you do it.
Gotcha. So basically, you register with the whitelist of the allowed return addresses.
Which is really annoying for local testing.
Yep. Yep. I can see why. Any questions? All right. So thank you, folks. And there is more pizza, or is it done?